Alright, so this video is going to cover this Chapter 14 Recursion Practice Quiz number 5. Now, the first few of these are just pretty easy, but it gets harder, much harder. So, this one has probably the hardest questions on here, so let's go through this. First couple are pretty easy, so I'm just going to copy this, and again, I'm not going to write all this out because I've got the answers down here, and it's probably best just for me to go through how I came to the answers in the first place instead of just, excuse me, I'm a sneeze, sorry. Okay, so it's probably best for me to just go through this. So, let's see here. It looks like, so 5 gets passed into result. And you guys have seen me write these out a bunch. So anyway, I've got my, if n is 1, then return 2. Else, return 2 times result n minus 1. So n is 5. N is not equal to 1, so we would do 2 times the result, which is 5 minus 1, gives us 4. 4 is not equal to 1, so we do 2 times the result. 4 minus 1 is 3. 3 is not equal to 1, so 2 times result. 3 minus 1 is 2. 2 is not equal to 1, so we do 2 times result. 2 minus 1, and we get 1 here. 1 is equal to 1, so we return 2. 2 is set to basically this right here. So you do 2 times 2 is 4. And so this is 4 right here. So then we do 2 times 4 is 8. And then this is 8. 2 times 8 is 16. And this is 16. 2 times 16 is 32. So we go down the stack. Then we got to pop back up the stack. Final answer is 32. So your answer is B. Let's see. It's a question for A. For the method call result 6, how many calls to result will be made, including the original? What did I put down? What's A? 6? So here's the first, call, I guess. So 1, 2, 3, 4, 5, 6. 2 is A is 6. Okay. I apologize. The first time through here, this was 6 when it was called, but 6 gets passed in, and then 6 minus 1 is 5. So that's where I got that. So that was the original. I didn't put that in, but whatever. Or did it change to... This was 5 and this is 6. Sorry. So I did the, yeah. So anyway, if you do this, it's doing it 6 times. This one was 5 times. 3. Yeah, look at 3. Looks awful. It's not too bad though. Let's go through. Let's click and drag this stuff down. Recursion problems always look harder than they actually are. As long as you write out your tables, you should do fine. So let's do this for 3. All right, so and what's originally called to, so 5 and 3 are passed in here. So 5 is A, B is 3, so are they equal? No. Which one does it call first though, F1 or F2? F1 gets called first, so 5 and 3. So F1 gets, so 5 and 3, are they equal? No. So we do 5, so we do this right here, which is 5 plus F2, 5 minus 1 is 3. And so then this is calling F2, so when this gets passed in, P becomes 5 minus 1, which is 4. and Q is B, which never changed, so it's Q is 3. So is 4 less than 3? No. So then what do we do here? We don't do this one. We do return this one. So this goes to F1. So then we've got P is 4, 4 plus F1, which is 4 minus 2. This becomes 2. And so our new value for A is 2 right here. And then Q is 3, so B, it becomes B right there, so B is 3. And so are A and B equal? No. So then we do 2 plus F2, 2 minus 1 is 1, and 3, so P is 1 and Q is 3. And then is P less than Q? Is 1 less than 3? Yes, so we return 1 plus 3, which is 4. And that's it. There's no popping back up the stack or anything, because all you're doing is returning that. So 3 is, what did I put down? 3 is E. So I did. Oh, I don't know if I did that. Sorry, I take that back. I made a mistake here, which is weird. I didn't fill this in right. I don't know. It looks like I was going to, and I don't know if I just didn't fill it right or what. But let's merge these together. And so the last one was this return 1 plus 3, which gives us 4, right? And I said that we were going to have to pop back up, pop back up the stack, but we definitely are going to want to do that. So this return 4 would get passed into that. So then you'd have basically, if we're popping back up the stack, 2 plus F2, 2 minus 1, comma 3. And so that would be 2 plus our 4, which gives us 6. So let me put the shapes in here, because we definitely want to make sure that we're doing that. We'll make sure there's no fill there. And then draw, insert. We'll do that gives us that right there, right? Our 6. And then we got to, again, pop back up the stack here, which gives us 4 plus F1, 4 minus 2, comma 3. And that would give us 4 plus 6, which is 10. And shapes. This 6 and that gets pushed right there. Okay. And then finally, we've got 5 plus F2, 5 minus 1, comma, 3, which then gives us what? 5 plus 10, and that returns our 15. Okay, that makes more sense. I was sitting here looking at that going, that doesn't look right. So anyway, we get down to our base case, and then we start kind of going back up the stack with, whoops, you know what, I even did that wrong. I got to put that right there, that 4. Okay, so 4 gets passed in, 2 plus 4 is 6, 4 plus 6 is 10, 5 plus 10 is 15, and that's where I got E from. It was, and of 3 was E. Okay, I was looking at I was like, I didn't finish this. All right, next up, 4. Consider the method foo. All right, so now some of you math whizzes might be able to come up with a better way of doing this. Because my way works, but it's definitely a long way of doing it, and I'll just kind of go through this to. So we've got a recursive foo here, a recursive foo here, and then once we get those down to their base cases and all added up or whatever, then you'll add those together, and then you've got the recursive foo right there. Okay, so we just start with the first one, foo 3. So x is 3. If x is 1 or 3, then we return x. So we return 3 right there, okay? 4, we pass in 4. X is not 1 or 3, so we have to do 4 times foo 4 minus 1, which becomes 3. And then 3 into foo gives us x, basically, and that's where I did right here. So that gives us 3. So we pop back up the stack. We have 3's right here. That's basically that part of the recursion. So we got 4 times 3 is 12. So on this side you got 3, and on this side you got 12. Okay, so that gives us foo 15. All right. And so basically what I did was I went through all of these. So you're basically doing a, what's the mathematical thing when you put an exclamation point after the number? Let me look it up real quick. I'm going to pause the video and I'm going to look it up and come back to you. I can't remember. I can't remember what it's called, but basically if you do, you know, it's on the tip of my tongue. I'm going to remember it right when this video ends. But anyway, if you go down here, you get your return 3 and you pass it in 4 times 3, then you get, you know, basically it's, I'm trying to, like, there's an exclamation point at the end, like 15 times 14 times 13 times 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. But we're going to stop here. So anyway, this is the number I get to, and you're never going to get something like this on AP because they know that you're not going to have a calculator, all right? But our final number is this, I don't know, 6 trillion something, or it's even bigger than that. It's kind of ridiculous that they asked this question, but you know, either way. So 4A, the answers are these factorial. That's what it's called. 3 times 2 times 1. So most of these you can do in your head. So 15, if you were even to do a few of these, you would know that the number is going to be just giant, okay? You don't have to go all the way down even. You can just kind of see how big these numbers are going to end up getting. You know, so I don't know, 3 times 2 times 1 is 6. 4 times 2 times 4 times 3 is 12, times 2 is 24. 24 plus 6 is 30. Now this is going to be kind of a big one because you're going to have, well, this one 2, 7 factorial, and then whatever that number is, you factorial again, and this is going to be 30, and then you're going to factorial that number. So I got to be honest, I don't know. I mean, this is the answer. It's A. And the only reason I just kind of, I obviously had a computer in front of me and I could add all this stuff up, but basically if I did 15 factorial, I get that, and then if I divide it by 2 factorial, I get the answer there. And so then when I go through it all, this is the final answer. So that's how I'm able to check it, by doing this whole thing. Now, I'm just not sure I know, have a good... There's math kids out there that will have a better way of thinking about this, and maybe we talk about that in class and I can add it to this video. But your answer to this one is A. Let's see here. 5. What does 5 say? 5's not an easy one either. 5 and 6 refer to this. We're trying to write 3-digit adjacent to each other. The method write commas is supposed to print its non-negative int argument with commas properly inserted. Every 3 digits starting at the right, for example, the integer, that would be, okay, right comma does not always work as intended, however. Assuming no integer overflow, which of the following integer arguments will not be printed correctly? So 5, so I gathered all of these, and then I just kind of, I wrote out how I went through each of these. So, if 896 is passed into here, let's see, what do we get? 896. Is that less than 1,000? Yes, so it prints that. So that's where I got 896 from. That looks good, so it prints that. When I get this going on here, right here, is it less than 1,000? No. So then we write our digits. So we do what? We pass this in for 1,000. So if we did this, this would give us 251 here. Okay, so this number modulus 1,000, basically we would get rid of that because 1,000, there would be 1,251s in this thing, right? Because we got that. So anyway, I got 251. 251 divided by 1,000 is, or 100 is 2. 251 divided by 10 modulus 10, that's 5. So this would give us what? 25. That chops that off, gives us 25. And then, no, that's not right. I'm sorry. If we divided those, we get, yeah, we get 25, and 25 modulus 10. That should be 15, right? Let me see how I got this. All right, so I'm getting kind of confused here. So anyway, if we were to do this, this would be 1,000. So that's, if we just had 0, 0, 0 here, if you did 1,000 times this right here, which is 251,462, it would then strip off this remainder, okay? And so that's where 251 comes from. So 251 gets passed in, and if you divide it by 100, you would get 2, okay? And then 251 divided by 10, you get 25. And then 10 goes into 25 twice with a remainder of 5, so that's your 5. And then 251 modulus 10 goes in 25 times with a remainder of 1, so you put a comma there. Afterwards, s.o.p, comma. So that would give us our 251, comma. And then we would write, we would take that number, because we divide it by 1,000, and that gives us this number. It would basically chop off that 251 and just give us this. And we divide that by 1,000. We write comma that, so that gets passed back in. And then what do we do here? Where's it at? We call that again, that number in modulus, so we get rid of the first 1,000 space right there, or the remainder of it becomes this, because that's what's left on here. And so then we divide it out, we get 4. Divide that by 10, we get what? 46. 10 goes into 46 4 times with a remainder of 6. And then if we were to modulus that, we get 2 and then the comma. So anyway, this prints fine because the first and the last characters are the exact same, and then it kind of just skips the middle characters. I think this is the one that is going to print, because it's going to print screwed up. You can kind of go through this, but it's going to print 051365, and then this one will print 5 because the first 3 and the last 3 are the exact same. So so your answer for 5 is B. Sorry, not B. Your answer for 5 is C. It's that one. Okay, and it's because we got issues with the placement of some of our code. All right, so for the next one, what is it? 6. Let's see here. So which change given methods will cause method write with commas to work as intended? Interchange the lines, that and that. So this is where you kind of gotta plug and chug. So so n divided by 100 and n modulus 10. And so if we change those up, so let's just do the first example. Let's do this example right here, 278, right? So if we were to pass that in, that's not less than 278 modulus 1000 would give us 278. It would be passed in here, and then we would do this. So 278, if this line of code was up here and this line of code was down here, it would print 278 modulus 10 at first, which would give us 8. So 8 would be the first thing that would print. So that wouldn't work because the first number that prints is 278, not 8 and then whatever. I could keep going, but I'm not going to. So B, actually let's do, the answer is B, but let's kind of go through some of these. C, change the test in right commas to if n is greater than 1,000. So change the test in right commas So I'm trying to write commas to if it's greater than 1,000. So instead of less than 1,000, it'd be greater than 1,000. So I guess, I don't know, any number that'd be greater. So let's say my number was 1,000,000 or whatever. Is 1,000,000 greater than 1,000? Yes, so it'd print 1,000,000. So it'd print it fine. It just wouldn't print without. It wouldn't print with any. It wouldn't print any of the commas that we're looking for. So C doesn't work. So anything greater than 1,000 would print fine. But there'd be no commas, so C's wrong. So we got A and C are wrong. D, in the method that, change the lines, write that to, so in the comma, so they're saying what, D, we want to flip these. We want to flip this line and this line. Well, let's say we had this right here, okay? First time through, that's not that, okay, so we do 365,056, and we would divide that by 1,000, so we get 365, and that would be put in here. So 365 divided by 100 would give us 3. 365 divided by 10 would give us 36. Modulus 10 goes in 3 times, so it's 6. So 3, 6, and 365 modulus 10 would give us our 5. So that would print 365. And then we do a comma. Okay, we did this at first, and then we would do right here. This, remember, this would be down here now. So then we do 365,051. Modulus 1,000 would give us 365. So for D, if we were to do this and this, our final answer would be 365, 365, and that wouldn't be correct. So 6E, in the method write with commas, change the recursive call. So if we were to change this to, so we would change what? So instead of having a division, so this would give us, so first time through they give us 365, and then 360, this would also give you 365, 365, so that doesn't work. Anyway, so your answer for B, or for 6 is B. You would change these two. And just plug it in and test it. 7, this is probably the hardest one, so let's kind of go through this. So we've got a sketch that gets called A, 0, -0, or negative A, 0, and 2. It gets passed into here, and then if n is less than 0, then we draw the line, else we do this. So there's a lot of just kind of math and stuff that you got to do on this, and I wrote it out, but there's a couple ways to think about this, okay? And I don't know which way is the best for you, but again, this, like I said, is not the easiest problem, and so it kind of takes some work. So if this is our original that's passed in, okay, then this is what xm and xy are set to. So A plus negative A is 0, and plus 0 minus 0 gives us 0. So 0 divided by 2, xm is 0. And then we've got 0 plus 0 plus negative a minus a is negative 2a divided by 2. If we do negative 2a, or if we do negative 2 divided by 2, that gives us negative 1a, which is negative a, okay? So those get passed in. And then what we get, we've got our sketch. So we've got our values now, our x, y, and everything for sketch. So then we call sketch and we call it again, okay? So when I do that, I get this sketch right here, which, you know, if we go back in, we've got a plus 0 minus negative 2, which is really a minus negative 2 is a plus a. So we've got 2 positive a's, so you got 2a divided by 2, which when we divide that out, we just get a for xm, and we get, you know, negative a for ym. So you're gonna have to kind of go through these, all right? And the whole time, you know, n is being subtracted out. So finally n is 0, okay? So that's our first, you know, sketch, because we're gonna draw that out because x is 0. This is where our draw line gets hit. And so the values here are a, 0, a, and negative a. And so this is where I have 6 below here, where you can kind of go through and see how I end up getting this. This is number 6, okay? So if this is my value of x1, y1, x2, y2, a over is my x, and then 0 is my first point. And then I've got a over is my next x2 point, and then negative a down. That gives me my point right here. When we connect those together, that's where we get side 6 from, okay? And then, you know, you just got to keep going through and plugging and chugging this thing. And again, it's not an easy question to go through. This to me is easier to see and do, but it's kind of hard to figure out because, you know, like this in my head, like I have to write this down. I can't, you know, I have to write it down to see what my xm is. I have to write these equations out. So you'll have a question like this similar on the recursion test. So just practice it. Make sure you can work through that. And because what I'll do is I'll give you like the exact same question, and I'll change up, you know, like one thing here. And when I change that one thing up, it will create one of these different looking graphs. Okay, so for this one, your answer is B. And you know that right off the bat without even having to do that, because remember, we just got that first leg right there. Do any of the other graphs have one of those down there? Nope. So your answer would be B. It has that right there. Okay, so anyway, you can kind of go through these once you have the answers and kind of see how I got, you know, 7 is a over negative a down, that gives you that point right there, and then 0 over negative a down gives you that point, and when they connect they draw, and then you got basically 7 there. And then you can go up and figure out, you know, all the different steps. So anyway, this video is done. Make sure you practice this stuff. This is the hardest recursion quiz, so take care. Bye.